we'll be looking at hexadecimal. So for your OCR GCSE exam, you need to be able to convert positive denary whole numbers, so anything from 0 to 255, into 2-digit hexadecimal numbers and vice versa. You also need to be able to convert binary and hexadecimal equivalents of the same number, explain the use of hexadecimal numbers to represent binary numbers. So hexadecimal is what we call base 16 notation. So if you remember in the previous lesson, binary is what we call base 2 because it has two different values, so a 0 and a 1. Denary is base 10 because it has 10 different values, 0 all the way through to 9. So hexadecimal values, they follow the same value as decimal all the way up to 9, but then when you get to 10, it turns to A, 11 is B, 12 is C, D is 13, E is 14, and 15 is F. So the decimal numbers 10 to 15 are represented with the letters A to F. There are 16 values, hence why it's called base 16 notation system. So hexadecimal is widely used in computing because it's a much shorter way of representing a byte of data. If we think about how a byte of data is represented in binary, it has 8 digits. So for example, if you had 255, it will be 8 ones. However, if we were to represent that in hexadecimal, we could then represent it with just two digits. So hexadecimal works with nibbles, so each letter represents anything from 1 to 15 in binary. So 1111 is an F, and then 1111 is an F as well. So we can represent that with just F and F. It's a lot more compact and it's a lot more user friendly for the user. So the largest byte value is 255, and you can use hexadecimal numbers to represent up to this value. So the next set of hexadecimal values would then be 16 in decimal would become 10 in hexadecimal. That's because we've got one set of 16, remainder 0. 17 would therefore be 1 times 16, remainder 1, so therefore it would be 1, 1. 18 would be 1 times 16, remainder 2, so it'd be 1, 2, and then so forth. And then when you get to 26, for example, you have you have one set of 16, remainder 10, so 16 plus 10 is 26, so therefore A in hexadecimal is 10. So we have one set of 16 and then one set of 10, 26. So once we've gone past the first 16 numbers, a 1 is added in front of the next 16 numbers, similar to denary when we go from 0 to 9, and the next 10 numbers will have a 1 in front of them. So the next set of hexadecimal numbers would have a 2 in front of them. So 32 is the equivalent of 2 16s, so it's 2, remainder 0. 33 is 2 times 16, remainder 1, so it's 2, 1, not 21, 2, 1, and then so forth. When you get to 42, you've got 2 lots of 16s, remainder 10, so therefore 10 in hexadecimal is A, so it's 2A. So now you could stop the video and you can see if you can work out the next set. Okay, so hopefully you did pause the video and you've had a go at working this out. So 48 divided by 16 is 3, so it'd be 3, remainder 0, so it'd be 3, 0, and then so forth. The same process as you did before. So think about it like a calculator. So 0F would be the equivalent of 15 in decimal because F is equal to 1111, which is 15. 10 would be, 10 would be 16 in decimal because 1 times 16. 20 would be 32, 2 times 16. 30 would be 48, so 3 times 16, and so forth. Hopefully that makes it a lot easier to work out as well in your head. So if we did an exam question now, we could have convert 130 into hex. So what we know is that 130 is the equivalent of 128 plus 2. So if we put that into our grid, we'd have 128, 0, 0, 0, 0, 0, 0, and 0. So that's what it would be in binary to start with. And then all we do then is we split our 8-bit binary number into 2 4s, which is 2 nibbles. So therefore that becomes 8 plus 0 plus 0 plus 0 remains 8, and 0, 0, 2. So this therefore becomes 8, 2, not 82, 8, 2. Yep. The other way you could do it is you convert 130 into hexadecimal. So we do 130 divided by 16 is 8, remainder 2. So therefore 130 in hex is 8, 2. Hope that makes sense. If it doesn't, let me know in the comments and I'll see if I can improve the way I've explained that as well. So just remember, it's not 82, it's 8, 2. So the next one we could do is convert AF from hex into denary. So all we do here is we'd separate the A into its binary number. So we've got an 8 plus a 2, so it'd be 1, 0, 1, 0. And then F is equal to 15 in denary, so therefore that would be 1, 1, 1, 1. We then put that into an 8-bit binary number, so it become 1, 0, 1, 0, 1, 1, 1, 1. So then all we do is add our ones together. So we do 128 plus 32 plus 8 plus 4 plus 2 plus 1, which is 175. Okay. So we can also do the conversion into decimal the other way, like we looked at in the hexadecimal calculator. So we multiply the second hex digit, so the 2, by 16, and then we add the first digit to it. So we've got 2 times 16, which is 32, and then we've got E, which is equal to 14, so we just add the 14 and the 32 together, which gives us 46. So that's another way of doing it. So in summary, hex is mainly used in computing as a very convenient way of expressing a binary number in a compact form. It is quite straightforward to move between hex and binary numbers. Hex numbers run from 0 to F, or 15 decimal. 15 decimal is the same as 1111 in binary, i.e. the largest value of a nibble. So F hex is the same as 111. If 2 hexadecimal digits are used, then you simply need to combine the 2 nibbles together to produce the equivalent binary number. What I do now is I'll run through some simple, some example exam questions from some past exam papers, and hopefully that will give you some more examples to work with. Number into the hexadecimal value into the binary number. So the first one is 4, so it should be 0, 1, 0, 0. Then we know that A is equal to 10, so it will be 1 plus 0 plus 1 plus 0, because an 8 and a 2 equals 10. The second question says if 62 is a hex number, calculate its value as a denary number. You must show your working. So you get 1 mark for your working, 1 mark for your answer. So 6 times 16 is equal to 96. Okay, and then all we do then, we've got the 2, so we do 96 plus 2, which gives us 98. Okay, so remember that the first value is the number of 16s and the second number is the remainder. Or you could do it another way. You could break it down into 2 nibbles and then work out the value of that in a binary number. Slightly longer, but if you're not very good at maths, it might be a quicker way to do it. So we've got 4 and 2 for the 6, and then we've got 0, 0, 1, 0. And then all we do then is convert that into an 8-bit binary number. So 128, 64, 32, 16, 842. So we do 64 plus 32 plus 2, which gives you 98. The same way as we did it by timesing it by 16. So 2 different ways you can do it to get your answer. Number, calculate its value as a hex number. So we know that 62, we've got to try and work out how many 16s fit in to 62. So all we do is divide 62 by 16, which gives us 3. So we've got 3 of 16s, and then we've got a remainder of 14. So we know that 14 in hexadecimal would be an E, so therefore the value would be 3E, and that's how you work it out. Okay, so you get 1 mark for your working out, and then you get 1 mark for your actual answer. So 3E, and that's it. So the next question basically wants you to do it the other way around. So convert the hexadecimal number 3E into a decimal value. So we do 3 times 16, which is 48, just like we had above. And then we do E, which is equivalent of 14 in binary. So that would simply be 1 1 1 0. So 8 plus 4 plus 2 equals 14, and that's the answer that we need there. Okay, but hopefully you'll remember that E is 14 anyway. So 48 plus 14 equals 62. Okay, so the next question is it wants you to convert the binary number 10110101 to its hexadecimal equivalent. So the first step that you would do is just to break it down into two nibbles. So therefore we'd have an 8, a 4, a 2 and a 1 on each side, and then we just do 1 0 1 1, which is the first nibble, and then all we need to do then is work out what that's the equivalent to, and then we write on the other side 0 1 0 1. So we know that 8 plus 2 plus 1 is equal to 11, and on the other side we got 4 plus 1, which we know is equal to 5. Okay, and then all we do is convert that into the value. So we know that 11 is B, so the answer is B5.